The second representative application of computation is data mining. As you know, the term mining itself implies finding a mineral deposit, such as digging for and discovering diamonds. Data mining is to find the diamond-class log from massive amounts of data. Fields to which data mining has been applied are many. In business, for marketing and trend analysis, in industry, for process planning and various logistics. In biology and medical science, DNA analysis became a standard tool for various new findings, and protein-related data has been used for drug discovery, and so on. There are again good examples that a new and clear view is provided by computation. And seems like one can discover something interesting so long as there are enough data on a given subject. Oh, you might have heard something like this somewhere. Let's recall it. Maybe this gives us a hint to understand how to conduct data mining. Yes, when we discussed the cryptanalysis of Caesar cipher, we have said as long as you have enough English text to go by, you will find the most frequent character that would correspond to the letter E. Once you discover that, you will be able to tell how far the characters were shifted. That is the target key K for the cryptanalysis. How could we find the most frequent character? Yes, by counting. By counting the occurrences of each character, we could find the one that appears most. Now, this key K is in fact the law how a message is encrypted. So finding the key is, in other words, mining an important law from the data, that is a ciphertext. And counting is essential for this task. In general, counting is a fundamental method for data mining. Let me give you an example of data mining. Suppose we are given a database of 8,000 mushrooms, like this. About half of them are edible, that is non-poisonous mushrooms, and the other half are poisonous mushrooms. For each mushroom, this database records 20 features, such as its shape, the color of its cap, type of spots on its cap, and so on. Each line here corresponds one mushroom, and the values of each line represent the characteristics of the mushroom on those features. For example, the values of this column are the types of the spot on each mushroom's cap. Then our task is to find out a rule that would allow one to look at the mushroom and determine whether the mushroom is edible or poisonous. This is our data mining task. Here, a basic method is again counting. We count the number of mushrooms whose spot type is Y and edible or poisonous. Then we know, at least in the database, for example, that among all mushrooms with a spot type Y, 94% of them are poisonous and 6% are edible. In this way, we will be able to get the correlation data between each feature type and being edible or poisonous. Then, based on these correlation data, we will be able to find a good rule like this for characterizing poisonous mushrooms. After basic counting, the derivation of this type of rule may not be so easy. Yes, in fact, finding a perfect rule is an NP problem, and it is sometimes the case that this task is hardest among all NP problems. Well, it is not so difficult to see that finding a rule is an NP problem. This is because once you are given a rule, you can check its correctness easily by going through the database. And unfortunately, finding a perfect rule sometimes becomes very hard to compute. So if we believe P is not equal to NP, then there is no universal and efficient method for solving all data mining tasks. But we wish to solve a given data mining problem and find a rule anyway. Here, statistics and algorithm design would become important. Well, in our real life, compromise is important when facing something that cannot be overcome as it is. We may change our goal from the perfect rule to reasonably good rule. Here, the meaning of reasonably good becomes important, which is a subject of statistics. Also, we don't need a perfect algorithm that works in all cases. In computer science, through investigation of hard NP problems, several methods have been developed for designing such algorithms that work approximately or partially. Combining these investigations, researchers have obtained several useful pseudo-algorithms for data mining. This research subfield or techniques obtained there is usually called machine learning. I would again point out here that supercomputers are crucial for conducting some of the heavy and very important computations in data mining.